Hey everyone, and welcome to the third video of the top-down shooter tutorial that we're doing in Godot. I hope you are very excited for this episode because we are going to do some fun stuff like adding the ability to shoot and actually spawning bullets. So really going to start to feel, a little bit more like a game. If you are just joining, let me show you where we left off last time. So in our last video, we had added some code that let us actually move our character and rotated it around based on where the mouse is, which is cool. So we've got a lot of the player movement stuff in place. Now we just need to actually add some stuff for the player to do, like shooting. So that's going to be the main focus of our time today. And in order to do that, there's going to be an extra asset pack that we're going to have to download because the top-down shooter one that Kenney provides doesn't actually have any bullets or fire effects or particles. And those are things that we're going to want in our game just to give it kind of a better feel and really make it clear to the player what's happening, right? Like you wouldn't want a shooter where when you shot, like nothing happened. Like that would be really terrible. It wouldn't feel good and the feedback wouldn't be there. So we want to make sure we're kind of adding at least basic versions of that as we go. So I'll have the image up on the screen and the link will be in the description below to get the tanks pack from Kenney, which is what we're going to use primarily not for the tanks, but just for some of the bullets and other effects that he has in there. So I downloaded the tanks redux pack right here, and so you can see I've got it in this Kenney top-down tanks, etc., all this in here, and we're going to get to that in just a second. But the first thing we need to do is actually add code that will let us shoot a bullet, that'll let us attack. And in order to do that, we're going to come back to our project settings and add another input for attacking. So there are already inputs here by default that come with a mouse click, I believe. Actually, that might not be the case. Okay, well, no matter either way, we're going to add a new one. I like having explicit inputs for everything I do, even if some of those things might be overlapping. Maybe you have enter that does one thing if you're in a menu and one thing somewhere else. I like to still make those explicit because then the label that you're using when you're actually calling those strings from within your code is very clear, like what action you're calling. So we're going to add one here that's just shoot. I'm going to add that, and we're just going to make this be a mouse button, and it'll be left button. So now, whenever the player left clicks, we will be a shoot event, basically, will get fired off. So now we can actually listen to that in our code. And this is where, in the previous video, when I was talking about different input handling and ways you can do it, this is where we're going to actually start using input handling that is not in our process function. So what I want to do is add a function, unhandled input, and you should see this autocomplete because it's a built-in function for any node, I believe, in Godot. And so what this means is that we're not going to be calling the code in this every single frame like we are in process, which gets run every frame for every node that has a script attached to it. Instead, this unhandled input function is going to get called whenever there's an input event that happens and it gets to this, like it gets to our player and nothing has handled it yet. So we're only going to call this and only going to process our logic here when we really need it. So for performance sake, not that we really have to worry about that right now, but just trying to write good code, as early as we can. This is going to let us write code that is more efficient when we're actually handling inputs. So the way that we handle inputs in our unhandled input looks slightly different than it does up here in our process function. So instead of looking at our input object, we're actually going to look at the specific event that this function is getting called with. So unhandled input gets called once per event. So you can actually just listen and work on the event that gets passed in. So we can say if event is action released shoot. It should just, whoops. There we go. So basically when the shoot button is released, and you'll notice that I'm doing it on release and not press. It doesn't really matter in this case. This just means that you'll shoot when you lift your finger off the left mouse button instead of when you press down on it. But we want to do released or pressed, not like, we don't want it to hold down right now. So I'll just do released. And then when we do release it, we actually want to shoot. Of course, we don't have the functionality to do that yet, but what I'm going to do just to stub that out is just add another function that I'm going to call shoot. Okay, and there we go. All right, and now we can actually fill this in with the functionality that we want. Okay, so now that we have our shoot function, we can actually call that here. So we'll call that every time the player shoots. And just for testing purposes, we can just add a print statement here saying something like the player shot. Real poetry right there. And I can run this. And if I click, we'll see the player shot appear down below. Sweet. Cool. All right, so now we have just our basic shooting functionality there. Obviously, it's not doing anything. But before we actually add anything else here to the player script, I think we really just need to add something to shoot, a bullet. So what I'm going to do is select our main node, and then I'm going to add as a child of that an area 2D. And what an area 2D is it's something that can still detect collisions, but it doesn't actually cause collisions. So I guess a better way to say that is it detects overlaps. It detects when other physics bodies or even other areas enter it or exit it, but it doesn't actually cause a collision. So like if two areas hit each other, or a kinematic body like our player enters an area, it's not going to stop it. Like it's not going to have a hard collision. So they're really good if you have like a pickup, for example, like a health pickup, or it's good if you want some kind of a trigger where when the player walks here, you should do something, or really just infinite amount of cases where you want to be able to detect when a player or something has entered a certain space or exited it. And so that's what an area 2D is good for. So with that, let me name this bullet. Okay. And similar to our player, we still have to give it a collision shape. So I'll do that. Collision shape 2D. And before we set the collision shape, let's also give this a sprite. And here's where I'm going to make use of the tanks pack. So I'm going to grab Kenney top-down tanks, come over to a sprite sheet, and I'll do, I think, only objects default was the one. There we go. So I think the one that I want to use, typically you want, it's kind of hard to notice bullets if they are really dark, even though real life, bullets are technically dark metal. Typically, bullets are also flying really fast and they're emitting a lot of energy, and there's lights and they're bright and they're loud, and you want it to be something the player notices. Like if there's a bullet, you want to give them a chance to dodge it or see where it's coming from. So you want it to be something noticeable and that emits some kind of it's something that you can notice and see. And so because of that, I think the one I'm going to use now, there's a light gray one in here somewhere. Oh, this one right here. So what I'm going to do, similar as before, enable our texture region, pop open this texture region button that will appear, and zoom in. Ooh, that's very sensitive. And so I'm going to have to bring our step down a little bit because this is a pretty small image, and I'll just drag right there. Perfect. Cool. So that'll be our bullet for now. And now I can actually give it a collision shape. We'll make this one a rectangle too. I'll make this smaller. And so you'll see that our current grid step for our main area is also too big. So how I can change that up here by hitting this little snapping options button, coming into configure snap, and changing our step here. I'm just gonna do, let's see, 4. I know I had a 2 down below, but I think 4 will be okay. Yeah, I think that's fine for now to give it a little bit of a leeway, and we can make it smaller later on if we need. You don't want to keep your grid step too small, or at least keep it small. If you have to make it smaller just to adjust something like this, that's fine. Usually you want to bump it back up, because if you zoom out, you're going to start getting some significant lag when the editor has to draw so many grid lines, but 4 is not really that bad. Okay, so now that we have our bullet, what I'm actually going to do, because we don't want to have a bullet just sitting here, obviously, I'm going to save this as its own scene. And in order to do that, you can right click on it and then come down to save branch's own scene. And what that will do is it will save not just, your parent node, but any child nodes, like the entire node tree as its own scene. So I'm going to do this and save it as bullet.tscn. And now we just have the bullet. It's become a node basically in itself. All those nodes we added still exist under the hood, but now you're just interacting with it as a whole. And if you ever want to edit the bullet again, you can either find it in your project dropdown in your folders over here, or you can actually just hit this little scene icon here, which will pop it open in the editor. And this is one of the best things about Godot, is that you can edit individual scenes and you can play them. So we're going to do the same thing with our player here. I'm going to save branch's scene. We'll make a player scene. And now I can either run our main scene by hitting, Command B or running the whole project. But what I can also do is if I go to our player scene, you'll see there's a run scene button, which is Command R. And if I do that, it's just the player. So this is a way that you can test and work with subsets of your, main scene. You can run individual scenes. Like if you're editing player controls and don't want to start the whole game up, you can just run an individual scene, which is just a really nice feature of Godot. It makes it easy to work on individual parts of your game or scenes at a time. So now that we have both of those saved off as their own scene, we can come back over here. And what we're going to do is go back into our player scene. First, I'm going to delete this because we don't actually want it there. We can come into our player scene. And what I'm going to do is save a reference off to our bullet. So similar to with our speed variable, I'm going to create another export variable, export packed scene var bullets. And so what a packed scene is it's a reference to a scene itself. Not one that's in game, but it's a reference to like the scene data. And what you can then do is instantiate or create individual instances of that packed scene as actual scenes in your game. So what we're going to do is come over to our player, and you'll see now that I've got an empty bullet variable here on the right, and I can load in a packed scene. I can just drag it, but I'll load it, this bullet that we created. And so now, like, we have this reference to the bullet scene that we created right here, and now we can reference that from within our code and create new instances of that bullet scene. And that's exactly what we're going to do. So I'll come down here, and now in our code, when we shoot, what I'm actually going to do is say var bullet instance. And I guess the actual GD script formatting is that when you're referencing a packed scene, that you uppercase it, since it's a scene, similar to how kinematic body is uppercased, for example, or vector2 is. Like whenever you're referring to a class or a node, you uppercase it. So we'll have a reference to our specific bullet instance, which will be bullet.instance. Cool. So it doesn't give you autocomplete, but this instance is the function you call on any packed scene to create a version of it. So now once this code gets run, we're going to create a new bullet and save it to our bullet instance. But if you were to run it right now and you clicked, you wouldn't actually see any bullets appear. And the reason why is because it's not enough just to create an instance of a bullet. You actually have to add it to your scene tree. So by default, when you create something, that scene is created, but it's not actually rendered onto the screen. It's not added to the scene tree. And in order to do that, we just need to do, you need to add it as a child of something. What we want to do is add it as a child of main. Just for the sake of quickness, I'm actually going to add it to our player. So I'm just going to call add child from the player and add our bullet instance. And now if I run this, we should see bullets appear. Oh, whoops. It appears that you know what? It's because I changed the name of bullet and then I have to drag bullet back in. That was my bad. So we got that. Okay, now this time when I click, you'll see bullets appear, and they're appearing on my face, which is not ideal, but there are bullets that are getting spawned. So now what we need to do is actually have those bullets go somewhere. And I don't think we're going to get the full bullet shooting functionality in, just because this video is going to get kind of long. But what I want to do is just have it where when we click, a bullet is spawned and it moves, and that'll be it for now. And then in the next video we can worry about actually spawning our bullets as children of our main scene and actually have them, you know, do some more handling and fun stuff with them. So for this video, what I want to do is just have our bullets spawn at a given point and go in a certain direction. So in order to do that, I'm going to come into our player scene here, and I'm going to add, this is a really common thing you'll see. I'm going to add a point 2D, or a position 2D, excuse me. I'm going to call this end of gun. And what I'm going to do is drag this around. So this is our point right here. I'm going to move it. I'm going to turn off grid snap for just a second. Let's just do this manually. Right there. That looks good. So here is going to be like an end of gun point. And what I want to do is have our bullets spawn here. I don't want them to spawn here. I don't even really want them to spawn here. It doesn't, you know, it kind of looks weird if they're coming like through the gun. You kind of just want them to start and spawn and appear like right at the end of the barrel. So I want to do that. And so what I can do to reference a node in our scene tree is I can use the onReady keyword and say onReady var end, I guess it should be end of gun, and I'll set this to be end of gun. And so what this line is doing is, one, we're getting a reference to our end of gun node. That's what this is right here. If you use the $, it's basically a shortcut to select nodes within the current tree. And so it's just going to find whichever node is a child of the node that has the script, which is our player. So it's going to find the child named end of gun and save that to a reference here. And the reason that we use onReady is because we only want to get this reference and use it when our gun is actually ready. And what being ready means is that it is in the scene tree, it is good to go, it's not still initializing. I'm sure later on we'll kind of get more into that, what it means to be ready, but for now this will be good. And so what we want to do when we add our bullet instance is we actually want to set our bullet instance's position. So I'm going to do global position, set that equal to end of gun dot global position. Okay, and now oops, I must have messed something up. Oh yeah, I totally got rid of that parenthesis. It's fine, can't type today. So now we'll see the bullet spawn at the end of our gun, which is great. So that's working. Obviously it's still not right, or not exactly where we want it to be. But the last thing we'll do is just give our bullet some velocity when it spawns. So when we shoot, we want the bullet to head towards where the mouse is. So what we want to do is when we shoot, we want to store where our mouse is. So for example, I can say var target equals get global mouse position. We'll use that same function we did before. So this will be a vector2 position of our mouse. And what we can do is say something like var, direction to mouse. So right here is getting where our mouse is, but now we actually need to get the direction to. And hopefully you are at least familiar with some pretty simple vector math. So in order to do that, we can just do target minus end, or I guess what we really want to do is bullet instance.global position. So we're getting basically the position of our mouse and the position of our bullet, and then subtracting our bullet's position from the target's position to get the angle to, like the vector, the direction vector towards it. Actually though, the nice thing is that Godot basically gives you a convenience wrapper over this exact thing, where we can do bullet instance dot direction, dot global position dot direction, geez, can't type, direction to, and then we can give it target. And this is doing the exact same thing that we just did. You're just giving it a vector, you're calling it on a vector2. So we're taking the global position of our bullet and getting the direction to our target, which will just also return a vector, which we can then normalize And then so now we have a direction to our mouse. And the last thing we need to do is actually give some speed to our bullet. And we're not going to be able to do that from our player script. So we're going to need to add a bullet script. So if I come over to our bullet scene, I'm going to add a script there. And here we'll also have, similar to our player, a export int var speed. We'll set this to be 300, so it's not lightning fast, but definitely faster than the player, which we used 100. And then what we can do is just do this for now, and we'll use our process function. I'll uncomment this out, and we can just do, oh, actually, I switched the order of that around. First, we need to expose some kind of a function here that lets us set the direction. So it's not enough just to have a speed, right? We need a direction. And so what I'm also going to do is just say var direction, which is just going to be a vector2, and I'll just say vector2.0 right now. So it'll just start as an empty vector. And I'm going to have a function up here that will just be func set direction, and this will take direction vector2, and here you can say self.direction equals direction. I'm not really good with names, so I usually just do this where I just call the parameter the same thing as the actual field we're going to overwrite, and then in order to do that you can just use self to reference the field versus the parameter, like the one we have saved on this actual script. And so now we have this function where we can call it, pass in a direction, and set that as our direction. And now in our process function, what we can do is say if direction does not equal vector2.0. So we only want to move if we actually have a direction, right? Otherwise, there's no point. So if we have a direction, then we can set our velocity to be our direction vector times our speed. And now that we have that, we can actually adjust our position. So area 2Ds don't expose like a move and slide function like kinematic bodies do, so we just have to manually add or change our position. So what we can do is just say global position equals plus equals velocity, and then it'll just add this vector into its global position. And that's going to work for us because this direction vector will be negative, if it's heading left or up or something. So adding it will be totally fine because the direction will, have the right sign. It'll be negative or positive in the way we need. And then we can just multiply by our speed. So now we have this. There's probably some people watching this that are screaming about me doing this in process, and I feel you. We'll get back to that. But right now, we just want to make sure we can actually spawn this bullet. So we have the ability to set the direction, and it should be moving once the direction is set. So on our player, we can actually now say bullet instance.set direction, and we're going to give it a direction to mouse. And once we do that, we should see it moving very quickly. Okay, so you can see, I don't even know if you can see that on the screen, but you can see it moving in the right direction, but it is lightning quick. And so one of the big reasons why, this is not the whole reason why, but one of the big reasons why is because we are doing all this code in our process function. So process is really good for things that need to happen every frame, like we've talked about. But whenever you are moving something that ties into the physics engine somehow, you want to do it in a function actually called physics process. And the reason why is because process gets called a certain amount of times per second, and that value goes up and down. That's what your FPS is, your frames per second. And so if you've got a really high FPS, you're going to call process a lot more. And if it's really low, you'll only call it a few times a second. And what that means is that our bullet is going to be faster or slower at any given time, depending on what your FPS is. And we don't want that, right? We always want our bullet to have the exact same speed. And so the way we can do that is by changing this to be physics process. And what physics process is, it's a function that gets called at fixed time intervals. So only every few seconds rather than few frames, or not every few seconds, like milliseconds. And it basically ensures that you always have a constant rate of things. And so whenever you've got something that should be constant, basically anything that involves movement, really, you want to do it in physics. Obviously anything that is, using the physics engine, you want to do it in physics process. Oh, whoops, I accidentally got rid of this. But so now this isn't going to fix our issue, but it should at least be a little bit, okay, no, it's not better at all. Totally fine. But that is still something we needed to change. The reason our bullet is lightning quick is because we were giving it this really high value that's going to be like, basically every physics tick, it's going to move like 300 units of measurement, 300 pixels basically, which is a whole lot. So let's just try keeping it at 10 and see how that goes. And that's a lot better. Cool. Okay, so we can see we have a bullet, it's getting shot. We definitely still need to work on actually rotating our bullet, but it's getting shot and it's going in the direction of the mouse. A really not good thing you might notice is that when I move the mouse, all the existing bullets move with it, which is very much not what we want. And the reason that that is happening is because of the thing I was talking about just a little bit ago, because we are setting our bullets to be children of our player. So children by default have the same scale and transform as their parents, like the same relative transform. So that means that whenever we rotate a parent, all the children get rotated by that exact same amount. And whenever we move a parent, 10 units up, all the children go 10 units up. So that's really bad for a bullet, because since we're rotating our player to face our mouse, it means that our bullets are also going to be rotated to face our mouse, which is obviously not conducive to a shooter. So that's something we'll tackle in the next video. We'll tackle, changing over our player. This also should use our physics process. We'll tackle rotating our bullets. We'll tackle making them children of our main scene. And with that, we'll start looking at connections and signals and start doing that. And then hopefully by the end of it, we've got a shooting system that works and bullets that feel good and that are getting recycled after they've been around for a while. So anyway, whoo, what a video. This one got packed with a lot more stuff I thought, but thanks so much for hanging around and listening and sticking till the end. I'll try and keep them a little bit shorter going forward, but appreciate your time. Hope this was helpful, and take care, everyone.